Welcome to today's workshop, How to Build a Location-Aware IoT Ecosystem with HERE and AWS. My name is Daniela Bentrup. I'm Senior Marketing Specialist at HERE Technologies. If you have any questions during the session, please feel free to put them in the chat window, and we'll save some time at the end to answer them for you. We are recording this event and will share the video in the next days. In this workshop, we'll explore how to integrate the location services and analytics in an IoT ecosystem consisting of an IoT edge device, AWS, and user application. And with that, I'd like to introduce Vidhan Bhonsle, Senior Developer Evangelist at HERE. Vidhan, I pass it to you.
Thank you, Daniela. Hello, everyone. I am Vidhan, and I am Senior Developer Evangelist at HERE Technologies. Let me talk about what we are going to do today. We are going to talk about IoT. Now, what is IoT? IoT stands for Internet of Things, and it is basically a smart network of devices communicating with each other. We always had device-to-device communication or machine-to-machine communication, but during recent years, things have changed. What has changed? Now we want devices to communicate with each other in a far better way, in a far efficient way, and that is where IoT comes into picture. And it is a huge technology which covers almost all the new age technologies that you can think of. You talk about machine learning, you talk about AI, you talk about augmented reality, virtual reality, cloud computing, DevOps, everything nowadays can be considered under IoT. That is how big IoT is. Now let's talk about what we are going to do today. So we have a very simple architecture that we are going to implement where we have IoT edge device. It could be your laptop, desktop, your PC. In my case, it's going to be a Raspberry Pi. And ideally, an IoT edge device or IoT endpoint could be a very small microcontroller-based device, which is MCU, which can be programmed in C, C++ language. So you can go for Node MCU, you can go for any Arduino-based board, you can go for Texas Instruments-based microcontroller, or you can go for SBC, which is called single board computer. And that is what we are going to use. And one of the SBC that we're going to use is called Raspberry Pi, and we're going to use Raspberry Pi 4. While coding on SBC or single board computer, since it hosts a complete, fully fledged operating system, we can run any programming language. So the language that we have chosen is Python for this. We'll have an IoT edge device sending data to IoT cloud. Now, this cloud could be any cloud. You can choose for any cloud or any server, but in our case today, we are going to work with AWS IoT Broker, or we're going to work with aws.amazon.com, and we're going to create AWS IoT devices or things, and we're going to use its services. And after that, once we have the communication where our IoT device is sending data to the cloud, then we are going to see how to handle that data on the user interface. And here is where we're going to integrate location services. So the first part is where we're going to concentrate on device sending data to IoT cloud. In this, what we're going to do is we'll have a device which will be acting as a publisher. So basically, we are going to work with publisher-scribe architecture, where our IoT device is going to be a publisher. Now, when we talk about pub/sub architecture or publisher, then we are basically talking about MQTT protocol. So we are going to work with MQTT protocol, which I'm going to show you while coding. Then our IoT cloud is going to act as a broker. That is what we're going to do. So let's go back to our screen. Kindly open your aws.amazon.com and log into your account. Here, what we need to do is first we need to create a thing. So we have a Raspberry Pi, or you can run this on your own PC where you have to have Python installed. Okay. And first thing that you need to do, we need to download a few of the things. So create a folder somewhere where you can save the files that we're going to create. Now in the console, you have to search for IoT. Okay, you'll have to click on the services and you'll have to search for IoT. And ideally, these are at the right bottom. You can see Internet of Things section. So AWS has a complete section for Internet of Things. And you can see a lot of things here, and we are interested in IoT core. So kindly click on this. So what are we doing here? We are basically going to create a publisher, which is going to run on our Raspberry Pi or on desktop. And for this, we have to download a few of the files which are going to get generated on AWS. And these files are going to help us in having a secure communication with our server. Now, the first thing that you need to do is you have to have your dashboard open for AWS IoT. And this is how it looks like. You have to click on Onboard, and we click on Onboard, and click on Get Started. So before we start coding, we simply have to work with this. Click on, you will reach this page, which is called AWS IoT, Connect to AWS IoT, and you'll see a few of the things here. One is onboard a device. Another one is onboard many devices. So what you need to do is you need to onboard a single device. We're not dealing with a fleet of devices. So click on Get Started. The reason that we are using this is because this is one of the quickest way of getting started with AWS IoT. You'll see a bunch of informations which are required here. And these are basically the steps. The first step is to register a device. Second is download a connection kit. And third is configure and test your device. So let's get started. So the first thing that you're going to do is you're going to select your operating system and the language that you're going to code in. So if you're working on Linux-based operating system or Mac or Raspberry Pi, you can click on Linux/OS X, or if you are using Windows-based operating system, click on Windows. So right now I'm using Windows. I'm going to click on Windows. Next, you have to select the language in which you want your IoT SDK. Although we won't be using IoT device SDK, but still we need a connection kit. So we are going to follow these steps, and I'm going to click on Python. Scroll down and click on Next. Once you are on this page, which is called Register a Thing, what you need to do is you need to give a name to your device, your virtual device. When I say a thing, a virtual device, it's basically, you can compare it with your digital twin. It's all about perspective. You can call it a virtual thing. A thing is what we say, the thing in Internet of Things, right? This is the same thing. Or you can call it digital twin. So I'm going to call it a thing, and I'm going to register a thing. So this is going to be a virtual copy of my physical device, which is there, which is basically a Raspberry Pi or your laptop, which will be acting as an IoT device. So I'll give it a name. I'll give it a name as any name you can give. I'll name it as Bella. And then you have to click on Next Step. Now here you'll see a bunch of information, and it's basically a step where you need to download a connection kit. You'll see a policy. We are going to change this policy. You can explore this. You can see that, okay, it has a lot of information on version and a lot more details, and it kind of look a bit confusing. And to be honest, it controls how you are going to communicate with your broker. It lets you control if the person or the device who's communicating with your broker, AWS broker, is real or not. You can limit it. So we are going to change this. But right now, let it be same. If you scroll down, you'll see a section called Connection Kit. Now, this connection kit contains a lot of information, important files, which are required for authentication and authorization from our device to communicate with AWS IoT broker. You need to have certificate and private key. That is what we are going to generate. And its name is going to be bella.crt.pem, bella.private.key. And you'll also get a public key. Apart from that, these two files are something that we'll get, but we won't be needing it. So simply click on Windows and you will be able to download this. And the size of this file is not much. You can see that it's only 3.6 KB. So I'm going to download this, and you can do the same. And I'm going to keep it in a particular folder. You can take a few minutes to do the same. So once you have downloaded this, you have to keep it in a specific folder. I've already done that. You can see that my connection kit is here. Next thing that you need to do is you need to unzip it or extract all what is inside there. Simply unzip it, or you can use RAR, anything you can use. And you'll find a lot of files out there. Okay. Okay, so you can see that we have a lot of files, and Bella is the name of the thing that we gave. You have a certificate file, you have a private file, you have a public file, which is basically key. And these are the three things. And actually, you'll get four things, which is the fourth one is start.ps1. Now, what you need to do is you need to open your PowerShell if you're working with Windows. So I'm going to open my PowerShell. And you need to go to this particular directory in PowerShell, and you need to run a few commands here. Or you can open it. You can open it in command prompt. It's up to you. The purpose of this file, if you explore this, is to simply grab two things. So I'm exploring this file. One thing, what it does, it basically creates and download a file and names it as root CA certificate. And the second thing that it does, it clones a GitHub repository and downloads the device SDK. That is all we need. So instead of downloading from here, what you can do is you can go to the GitHub link, which we have shared with you, or Daniel is going to share with you, and you can simply download this root CA certificate, which I have already provided here. And it looks like this. Now it is going to be common for all of us. You can simply download it from here. Can you do that? And it is going to look like this. So these are the files that are required. Now you can follow the steps which are provided in the GitHub link. Scroll down, and there are a few things that you need to do. One is we have to create a thing, and that is what we have done. And while creating the thing, we have also acquired these 4 files. That is something that you need to do. The second thing that we need to do, or the step 2, is we have to create a publisher. So what you can do is you can check geocode_data_publish.py file, which you can find in the GitHub repository. Kindly download this file and keep it in the same location where we have kept our connection kits file. That is our certificates, our keys, and our root CA certificate. I have already done that. I'm going to open this. You can use any code editor. The code editor that I'm using is Visual Studio Code. You can use any code editor. You can use Notepad. I'll suggest not to use Notepad because you won't be able to do the proper indentation. I'll suggest either you use Notepad++ at the minimum, or you can use any IDE like PyCharm or Visual Studio Code or any IDE that you prefer. Now, this is the file that you all must have. We have already created our files. Now go back to your account, AWS, and click on Next. And let's finish this step. So that creates all the files which are required to have a secure communication with our AWS IoT. Next thing that you need to do is you need to go to the code. Now, this code is a very simple code. What it does, it uses few of the libraries that you can see in line 1, 2 through 6. First is we are importing a JSON for handling or converting our normal string into JSON string, and that's what we are going to send to our server. Next line is where we are actually working with MQTT. For that, you'll have to install MQTT as a library in Python, and you can find details on GitHub link. If you scroll down, you'll find in step 2, you have to run command pip install paho_mqtt. I'm going to run this just to show you. That's what you have to run. Although I already have this library, but you might not have it. So kindly install it with the help of this command. And for this, you should have your pip enabled in your system. The next thing that you need to do is we have a bunch of things here which you need to provide values to. You have your client ID, you have your thing name, and you have your AWS host region. Let's edit these values, then we'll go through the code. Now, when we talk about AWS host, it's basically the location of the broker that we have. You can find the location on AWS IoT. Go to AWS IoT, go to settings in the dashboard, which is at the left bottom, and here you have what we call endpoint. Simply copy this, and this is the value that we need to put in our AWS host value. After that, you have client ID and thing name. So I gave my thing name as Bella. I'm going to leave it at Bella only. And you can give any client name, it's up to you. So I'm going to name it as Bella. And make sure that your geocode_data_publish.py and all the certificates files are in same path. Otherwise, you'll have to provide a complete path. Now, you have to give the name of your certificate file and key file, which is your thing name.cert.pem. So these are the values that you have to provide. Now let's talk about the code. The code is quite simple, where we have few of the standard libraries that we're using. That's Paho MQTT. And we are simply using onConnect to get connected with AWS IoT server. And then we have onMessage to handle the messages. And then we are creating an object of client class. And with the help of this object, we are going to communicate, or we are going to get connected with the AWS IoT broker. And we are going to have a lot of communication published data to it. And we are hard coding lat long values, although I'll suggest that you don't hard code it, but for the sake of ease of this workshop, we are keeping it as hard coded. Otherwise, you can simply attach a sensor to your, either you're using NodeMCU or ESP32 or any of a microcontroller, and you can pass this data. If you scroll down, you'll see that the communication is going to be secure communication, which is TLS, that is your transport layer security. So all the files which we have downloaded are going to be used for that secure communication. And then you have mqttc.connect. That is going to make your connection or your publisher or your IoT device get connected with AWS IoT broker. And lastly, we are going to make this happen in loop. That's going to be infinite loop. And then again, we are going to have an infinite loop. Now here is where we are actually generating the data, and we are generating data in every 5 seconds. And then we are converting the payload, or we are just creating a payload object by converting the data into JSON value as latitude and longitude. And then we are publishing it. So it's quite easy to work with MQTT library. And then we are building it for our ease. Once you have provided these values, all you need to do is you need to run this. Now, there's one more thing that you should be doing is you should be telling the topic name. When we talk about MQTT, you always publish data under a certain topic name, and the topic name that we have chosen here is called IoT. And the data that we are sending under this topic name is latitude, longitude value, and QoS is quality of service. We are keeping it as 0. Next thing that you need to do is you need to run this. Now, before running this, because this is going to give you error, you have to change the policy. So go back to your aws.amazon.com and go to Manage, click on Things, and select the thing that you have created. In my case, it is Bella. And here you have to go to Security. Click on Security. Under Security, you have a certain certificate which is created by AWS. Click on that certificate. Under Certificate, you have Policies. You can go to Policies from here, or you can simply go to Secure and click on Policies. And here also you can find the policy. This is my policy. Scroll down and you'll see that the policy is quite big here. And we don't want that because it is going to have a lot of restrictions and we don't want to work with that. So you're going to do one thing. You have to click on Edit Policy. But what are you going to paste it here? For that, go back to your GitHub link. And here I have created a file called policy.txt. Click on that file and copy this policy. So this is basically an open policy which is going to help you out in having a proper communication. Click on Edit, select all, and substitute it with the policy that's provided in the GitHub link. And click on Save as New Version. And it's going to get saved. This policy is in JSON format, so it's quite easy to work with. Once you're done with this, we are all ready for having a communication with our broker. I'm going to go to my code and we are going to run this. The value that you're going to get is connection result 0. Whenever you get 0 result, that means that your data or your communication with broker is successful. And you can see that the data that we are sending is this. Now let's check this data on the cloud. You'll have to go to your AWS account again, and to test it, you have a section called Test. Let's click on Test on the left menu. And here, since our device is acting as a publisher and AWS is acting as a broker, to read the data, you'll have to be a subscriber. And the topic to which you have to subscribe is called IoT. Click on Subscribe to the topic, and you should be able to see the values. You can see that the values are coming in here. Right now, we are only sending latitude and longitude data to keep it simple. But in ideal scenario, when you have IoT device, it should be sending a lot more values than this. It should be sending temperature, pressure, depending on your business use case or business scenario. So that completes our one part. Now, same thing I have done on Raspberry Pi. I'm going to quickly move over to Raspberry Pi. And make sure that you disconnect this. Otherwise, you'll get a lot of amount of bill. So I have a Raspberry Pi running and the same code is there. So I'm going to use a putty to access this. So this is the code for my Raspberry Pi, and it is doing the same thing. Only thing that is different is the thing name. The thing here is geocode, and there we had created the thing name as Bella. It's doing the same task. Now let's run this code. This is also generating latitude and longitude data. Let this code be running because now we're going to concentrate on the second half of our workshop. And that second half, let me open my slide. Now, what you have seen just now is how you can publish data to a broker. The data that we are publishing is what we call location data, which is latitude and longitude. Now we are moving to the second part where we are going to have our broker send data to our user interface. When I say broker send data to user interface, that means that our user interface is going to act as a subscriber, which is going to subscribe to a topic, which is IoT. And everything we're going to do, we're going to show it on a map. Now, whenever you talk about data analytics, you talk about creating or cleaning data, you talk about segregating data, you talk about collecting data, and then you talk about converting that data into information, and then that information into knowledge, and then that knowledge into an insight which can be fed into your business scenario, which could be of high value. So here we have location data. If you're going to read this, you won't be able to understand this because these are your geo coordinates. So what we need to do is we need to perform a basic data analytics where our let log is needed to be converted into something which we can visualize. So that is what we're going to do. And in doing so, what we're going to do is we are going to use HERE maps or HERE location services. Before starting, let me tell you a few things about HERE technologies. HERE technology is the world leader in location technology. And to give you a perspective, the maps or location services of HERE technologies are in more than 100 million cars over the world. And 4 out of 5 cars in Europe and North America uses our maps. How do we do that? How do we collect data? We have a fleet of 400 plus cars who collects data. Every car, every second, collects more than 700,000 3D data points. And in doing so, we collect 28 terabytes of map data every day. We have mapped more than 200 countries, and the number is still increasing. Now, the future is all about autonomous car for mobility, and that is why we are working really well. And we have mapped 600,000 plus kilometers in pure HD, that is high definition, just for autonomous driving. Now, how do we do that? Or what do we do with the data that we collect from our LiDAR-equipped cars? We send this data to our server. On our server, which is HERE server, our team of engineers and machine learning scientists and all these software developers, what they do is they create a map out of it, which is of different types. Apart from that, the data that we get, they perform a lot of data analytics on it so that you don't have to provide or do those analytics. You simply have to call those APIs and you can get the result. And then we package them into different formats which can be consumed by developers like you and me. The formats that you would want to create, either you would want to create a web-based application or desktop-based application. For that, we have JavaScript-based APIs. And then for our desktop-based application, we have REST APIs. And if you want to create a mobile-based application, for that, we have software development kit for Apple or iOS, Android, and a hybrid one for Flutter. So what you can build something like this. And that is what we're going to do. We're going to create a web application or application which is an HTML, which will run on your local machine. Let's talk about that. The next step that you need to follow, you need to go to your GitHub link, scroll down, and you have to go to step number 3, which is create a subscriber code. And for that, you have to copy or you have to download flaskserver.py file, which you can find in the GitHub repository. And this file I have already downloaded. And you'll have to change few values here. The values that you need to change is again the same thing. You have to change the value of your broker. So you can copy those values from your publisher code. Change those values. You have to change the client ID. Ideally, you can keep any ID, but to keep it uniform, keep it same. And you're going to skip or you're going to use the same certificates and keys that we generated. The reason that we are keeping the same certificate and keys is because we are communicating with the same broker or the same endpoint. And for authentication and authorization with the same broker, you need to have the same certificates. Now, this code is fairly simple and straightforward. For this, you have to import few things, the information you can find on your GitHub link. You have to install Flask MQTT, simply run pip install flask -MQTT, and you also need Flask, pip install Flask. Now, what is Flask? Flask is a micro web framework which is built in Python, and it's quite flexible and quite powerful. That is what we are using here. And if you scroll down, you can see that we are configuring the app that we have created here with all the values of the certificate. The bunch of values that you might not or you need not to change. Scroll down and we have initialized the latitude and longitude. Scroll down and you'll see that we have few methods here which are centered. One, to get connected. So we are letting our Flask server, which is basically a subscriber, get connected with our broker, which is AWS IoT. And at the same time, we are subscribing to a topic, which is IoT, because we are publishing to the same topic. If you scroll down, you have another function, which is called onMessage. And what this function does is we are going to get the data, and then we can simply pass the data we are getting, and we can assign it to a latitude and longitude. The data that we are sending, if you check the data that we are sending on your AWS, the data is in this format, which is a JSON. You can simply pass and you can take out the values since it is key value pair. And that is what we are doing here. And after that, we have one more, you can say that function, which is index. And here we are basically rendering a template called home.html. Now this home.html is going to be inside a folder called template. So what you need to do is you need to create a folder called template. Let me open this. And the folder should look like this. Inside this template folder, you have to keep your home.html file. Kindly download this also. The reason that we are keeping home.html file in template folder is because this is how Flask basically work. Flask only recognizes the HTML file if they are kept in templates folder. If you scroll down, you'll see one more link, which is basically for handling Ajax because we are getting real-time data. And for handling that, we are going to work with Ajax. And then we are simply running the app. That's it. Now, what this code is going to do is going to start a Flask server, and it's going to call home.html file. And that is what we're going to look at. So what I'm going to do is I'm going to open a structure which I have already created to save the time. And this is for geocode. That is my thing name here. And home.html is where you need to provide certain values. Kindly open home.html. Now this is an HTML page which is going to basically convert our lat long into something which we can see or which we are going to show on a map, a location. What you're going to see is a HTML page with header tag and a body tag. In head tag, you'll see certain scripts. If you look at line 6 to 10, these scripts are basically our mapping library in JavaScript, where we are calling different functions or classes which will be required for working with HERE maps, like map.js core, map.js service, map.js UI, or events, if we are going to use event listeners. And one more thing that you're going to see is you're going to see Ajax library, which are required for Ajax. If you scroll down under body tag, you'll see a container, and this container is where we're going to show the map, nothing much. And later in the script tag or script section, we are going to work our magic, which is of creating a map. Now here is where you are going to create your own structure. Now, for this, everyone, what you need to do is you need to sign up with developer.here.com, the link which I believe already is being shared with you in the chat. And you need to sign up. Let me quickly go through it, and you need to acquire an API key. So what you need to do is once you have signed up, which is basically a freemium account, and freemium account is one of the best freemium account. Here, you don't have to provide your card details. All you need to do is you need to provide your first name, your last name, your email ID, and a simple security check. and you'll get 250,000 transactions per month. Once you have signed up, next you need to do is you need to sign in or log in. After logging in, what you're going to see is you're going to see a project structure. In freemium account, you can only see one project, and that is what you are seeing on your screen. This is my freemium account. Project name is one. In your case, it might be different. When you click on this, it's going to open a credentials page. And here is the real magic happening. Whether you want to create a desktop app, you want to create a web app, you want to create a mobile app, you'll need a unique key to communicate with the HERE server, and those keys are here. So for our code right now, what you need is you need a JavaScript key. So you have to click on create API key, and it's going to create a key for you. You can create two keys. I can show it to you, and no worries because I can delete it later or I can disable it. It's quite easy. Copy it and paste it in a space where it's written HERE.js key. I have already done that. If you scroll down, you'll see a bunch of lines of code, which are basically for generating the default layer, because we're going to show a map and it's going to be on something. And that something is what we call default layer. And after that, we're going to give an initial location, which is somewhere in Bangalore. So I'm going to give us initial hard-coded location. And then we're going to monitor that location. It's up to you. So I'm going to skip this. If you scroll down, we need to create an object of map class, and we need to tell it that at what location this map has to be centered, and the location is somewhere in Bangalore, as I told previously. And you can define the zoom level. So zoom level varies from 1 to 20. So I'm selecting quite a zoomed view, which is 15. If you scroll down, you have 3 lines of code, which are basically for handling your drag, and these 2 lines are handling your drag events, right? That is for your event listener. And the first line is for zooming in, zooming out, and changing the layer. You're going to see this soon. And next, what we're doing is whenever we are getting the lat and long or latitude longitude data from our IoT broker, which is coming from our IoT end device, we are going to show it as a marker on our map. So what you need to do is you need to again create one more folder called static, and you need to put a file called home.png. It is an image file. And you can find it on our GitHub link. So kindly do that. You can find this file in static folder. Simply, you can download this and use it. Going back to our code, and then our actual work of refreshing our web page, or basically container, is happening here. This is basically the Ajax, which is playing here. We are grabbing the latitude longitude from this link, and we are passing this latitude longitude to refresh dt function. And in the refresh dt function, we are passing this, or this latitude longitude, we are splitting it into latitude longitude. And then what we are doing out of it, we are creating a marker at the new location that we are getting from our AWS IoT server. And the marker that we are creating at that location is going to look like a home icon, which we were talking about. And then we are adding this marker to our map object. That is what we are doing here. Let's run this code. Make sure that your publisher is running, because that is what is going to help you out. So my publisher is running. You can see here, the publisher data is running on Raspberry Pi. Let's run this code. All you need to do is type Python. I'm going to clear this. I'm going to make it big. Python Flask server, and hit enter. And what it's going to do is going to start a server on this particular link. That is one, which is basically a local host, which is 127.0.0.1, colon 5000. When you open this, you should be able to see an IoT user dashboard. Since we have not optimized the code much, you might not be able to see everything. Just a sec, I'm going to close this. I'm going to refresh this again so that you can see it. So basically what is happening is your publisher is sending latitude longitude data, which is my Raspberry Pi, to AWS IoT Broker, and Broker is simply acting as a connecting link between Raspberry Pi, which is publisher, and my desktop application, which is IoT User Dashboard. Since it is getting refreshed again and again, so it might take time to load because we are refreshing this particular container, div tag. And you can see that these are the data that we're getting. You can check in the console. Let's check this in the console. Let me check if we are monitoring it in console or not. Okay, we are not monitoring anything in console. So what I'm going to do is I'm going to see the lat long values that we're getting, and it should refresh. So you can see that this is the value that we are getting, and then we are passing this value or splitting this value, and these are the values which are getting plotted as marker. Now, this is a very simple, you can say that POC, which you can build, you can play around with. Now, there are a lot of things that you can do with this. If you'll ask me what are the things that you can do, you can simply go to developer.here.com. I will take you to developer.here.com. You can go to documentation, and there are a lot of things that you can do with this particular use case that I've shown you. One thing that you can do is you can have an asset, which could be your truck or commercial vehicle. You can capture the location of that. You can send to a server with, say, temperature and all the other values. And then on a user interface, you can basically monitor its movement, right? And you can have a routing to it, or where this particular vehicle is traveling with the help of routing API. You can play with routing API. You can basically see where your truck is traveling and how much time it is going to take, how much time it is taking. You can even calculate ETA, that is estimated time of arrival. It will be based on real-time traffic data. Apart from that, what else you would want to do? You would want to have a geofencing. That is something that I would do if I would have created this complete application, is to know if a certain vehicle has left a certain area. And that plays very well with geolocation, which basically creates a boundary of latitude and longitude, where if something moves out of it, it basically gives you an alert. Or let's say that you have a fleet of cars which you're monitoring, then you can play with Fleet Telematics API. You can have your custom locations where you have your delivery vehicles sending data or asset to a particular warehouse. Instead of you monitoring all the locations, you only have custom locations shown to you on a map, which are contextual, that you can build. Or you can also define a custom route that you want your vehicle to take a particular route. You can also define that. So all these things can be done with the help of HERE APIs. You can explore this. Apart from that, there are more things that you can do. Let me tell you about those, which you can take for support to resources. You can see the documentation, which I just showed you. You can go to GitHub link and you can see the examples for mobile development or desktop or web application development at GitHub. You simply have to search for github.com/heremaps. Or you can go for tutorials in the developer portal, which we have worked with. So our developer portal is one-stop shop for all your location-based needs. You can get resources from there. Or else you can go to developer blog, where you can find blogs written by me or by my fellow evangelists on different technologies. And that is what you can do. And lastly, you can go to all these resources to get started or to get help. You can join our Slack channel. Thank you, everyone.
Thank you, Vidhan, for the presentation. So everyone who's online, feel free to send your question. This is a good time now to do that in case you haven't done it yet. So far, we answered some questions in the chat already. And as mentioned before, this is a recording that we will share after the workshop. We send you an email, and then you will have the link to the recording itself. So I don't see any more questions then. So I would say thank you all for joining this workshop today, and have a good day then. Bye-bye.
Good day, everyone. Stay safe.